So 8 to the power of 0, anything to the power of 0 is 1. But then here, if you have a negative sign in front of the 8, then this is negative 1. Now, what if I write like this then? What would this equal? Yep. Positive 1 as well. Yes, because that negative is inside the bracket and it's also raised to the power of 0. So this gives you positive 1. Okay, so know the difference between these three. Okay, negative exponent. So whenever you have a negative exponent, it does not change your base sign. It doesn't. This being positive or negative has nothing to do with this negative right here. This is part of your exponent. What this tells you is it tells you to flip the base. That's all it tells you. It doesn't change it to positive or negative to positive. So my base right now is 4. If I flip the base, what does it become? Yeah, I heard it. 1 over 4. Yeah, I read lips. Okay, and what's my new exponent now? Yeah, just 1, right? Because we dealt with that negative, and so it becomes just the positive 1. And anything to the power of 1 is just itself. So 1 over 4. All right. So C, similarly, I see that negative exponent. That means I have to flip my base. What's my new base right now? But just the first step. Let's just write the first step. Just flipping the base. Okay, 1 over negative 2. Good. What's my exponent now? Positive 3. Right. When I have an exponent, when I have a fraction raised to an exponent, my exponent applies to both my numerator and denominator. So 1 times 1 times 1 is just 1. And negative 2 times negative 2 times negative 2? Negative 8. Good. Okay. So you could write it like this, or you could write it like this, or you could write it like this. Wow. Okay. These three all means the same thing, whether you have that negative on the denominator, numerator, or on the side. As long as there's just one negative, it means that these are all negative 1/8. Okay. So this one, I have a fraction base. You do the exact same thing. Flip the base. So what's my new base now? And my exponent? Good. Okay. A common mistake that people do is they put negative 2 after they flip the base. Then it doesn't make sense. You just flipped it without changing the question. And then 3 square over 2 square, which gives you the answer? Which gives you the answer? What's 3 over 2 to the power of 2? Yep.
9 over 4.
9 over 4. Okay. Another common mistake that people do is they do 3 times 2. Okay. Very common. Remember, it's 3 squared, so 3 times 3. 0 to the exponent negative 2. Okay, what do you guys think it equals? How many of you say it equals 0? How many of you say it equals 1? How many of you say it equals something else? Okay, so apparently I only have 2 students in the class. Okay. Well, let's follow the same rule.
It's undefined.
Okay, negative exponent means I have to flip my base. What's my base right now as a fraction? What's my base as a as a fraction? So what's this base number right here? 0 over. So if I were to write this as a fraction, yeah.
0 over something.
What is that something? What is that number? 1. Yeah.
Isn't that 3 times?
Oh, I thought you meant just like 1. Sorry. I didn't know you were talking about the denominator. Okay, so my base right now is 0 over 1. So when I flip it, it becomes 1 over 0 squared. And as you guys know from grade 9, what's 1 over 0? Undefined. Yes. So this question, 0 to the negative 2, is actually undefined. So it's not 0, not 1, it's undefined. Yep.
So 0 under, like, to the and negative powers under.
Yeah. 0 to any negative power is undefined. Okay. Last one. Okay. Somebody tell me what to do. Yep, Aryan.
First flip the base.
Mm-hmm.
So if we are negative 2, 4.
Yep.
And then you just, it's 3 to the power 4 is 81, so 81's on the top. And then on the bottom, since it's in brackets, the negative 2 would be completely encircled by the exponent, meaning that it would be negative 2 raised to the power 4, which would be 16.
Perfect. I love the explanation. All right. And because that negative is inside the bracket, that means it's negative 2 in bracket raised to the power of 4. So negative 2 times negative 2 times negative 2 times negative 2, which gives you positive 16. Perfect. Okay. Are we good with 0 and negative exponents? All right. So you guys are happy that it's on the next test? Okay. So let's do just 2-word problems right here. 2-word problems. The lac 41 is a radioactive element that decays to half or 2 to the negative 1 of its original amount after every 5,700 years. Determine the remaining mass of 10 grams of this after 28,500 years. Okay, so with these, there's a formula. Okay, T over N. Okay, so with these type of exponential growth or decay question, there's this formula that you can somewhat you can use. All right, AL represents the amount left at the end. Amount left. So AL, amount left. All right. What about this? This symbol, you use it in science. It's a 0 right here. So we call this A naught. All right. In science, what does that represent? What does that mean? Anyone know? You use it in science, A naught. All right. Starting value or initial amount? Initial amount. Okay. This right here, this bracket that I don't have. Oh, actually, yeah, you can actually use an R. Okay, is the rate, growing rate or decay rate? Growth or decay rate. Okay. T is the time, and N is how often. So how often it changes, how often it evolves. Okay.
What is this formula called?
Growth and decay formula. Okay. So based on this description right here, this word problem, let's plug in some numbers. Right? We're trying to determine the remaining mass after 28,500 years. So we're trying to look for AL. That's what we're solving for. So we'll keep that AL equal. What's my initial amount? How many grams were there at the beginning? 10. Yeah, so 10. Okay. What's the growth or decay rate? 2 to the power of negative 1. Good. Okay. How many years are we trying to figure? 28,500. And how often does it evolve? 5,700. Good. All right. So if we work this out, we have 10 times 2 to the negative 1 times. So when you do 28,500 divided by 5,700, you get 5. Okay, recall from the last chapter, what do you do when you have an exponent raised to another exponent? What do you do with these two? Multiply them. So 2 to the negative 5. Okay, so working with negative exponents, I know that this means the same as 1 over 2 to the power of 5. So you get 10 times 1 over 32, or just simply 10 over 32. Okay, 2 to the power of 5. Okay, 2 to the power of 5, yeah, 32. Okay, I can reduce this. So 5 over 16. What's my unit? Grams. Good job. Okay. So after this LAC 41 radioactive element decays and decays and decays and decays and decays 5 times, what's left is 5 and 16th gram only. Okay. Yeah.
What is the first A out arrow thing?
Oh, I'm out now. Sorry. Okay. So last example. The Keith 38 is a bacteria that's on your desk right now, and it's tripling every 20 minutes. If there's 20 grams of this at 9 a.m. this morning, how many grams of this bacteria is on your desk by lunchtime? Not that to scare you just right before lunch. Okay. So how would we set this up?
Does this actually exist?
No. But it does make you wash your hands. Okay, what's my initial amount? What's the initial amount? What? 20, yeah. 20 grams, good. What's the rate? What's the growth or decay rate? Yep. 3. Why is it 3?
Well, it triples.
That's right. Okay. So triples. That means the rate is 3. Okay. And then what is T and what is N? Arian. 180 over 20. That's right. Where did you get this 180 from? Yeah. So right here is from 9 a.m. to 12 p.m. That's 3 hours. But because it changes every 20 minutes, notice the units are different. So that's why we had to change it to the same unit. So 3 hours times 60 minutes in an hour, that's how you get that 180. So that means in the 3 hours, there's 180 minutes, and it changes every 20. So 20 times 3 to the power of 9. So if you do bad math correctly, you know that you're supposed to do 3 to the power of 9 first, exponent. Okay, 3 to the power of 9, you get that, times it by 20. So how much bacteria is on your desk? 393,660 grams. Ew. So wash your hands, people. And don't put your fingers in your mouth. I know your parents been telling you that since like grade 1. Alright.
School break if that happens.
No, the bacteria. If you use a magnifying glass, you'll see bacteria on everything. Oh, grams.
It doesn't say like one colony forming unit. It's in grams. So like there's nearly 400 kilograms.
That's
on
true.
the
20 grams.
But you know, after so many years of doing this example, nobody told me to change it to milligrams. I think milligrams.
Just change it to like colony forming units. I feel like that makes more sense than everything.
Yeah, nobody ever said that. Nobody ever said that if this was in actual grams, that it will inflate the whole classroom. So, but I see. That's why you guys are the gifted class. You guys think beyond the box.
Is this bacteria like poisonous? Does it kill us?
That's true. Maybe it's a friendly bacteria. Is there such thing? Yeah. There's such thing as like probiotics.
But like a lot of it.
I don't know about change it to CFUs. Don't change it. Like don't measure it by weight.
This is the weight of the bacteria in your body.
Oh, okay.
Grams of bacteria. Like that's enough to like shove your hand inside if you have like a pile of them.
Yeah.
Like that's enough to see. Like,
Yeah.
That's a lot of.
No, I mean the death would survive.
That's also fine. It will demolish. We will demolish.
Let's do it. What's going on?
10 to the power of negative 12.
Yeah, so when I do these examples, you guys have to let me know how I should change the questions for next year's students.
CFU. That's one way to measure like that.
Okay, so that's the lesson. Nonetheless,
If you had a fraction to like the power of -2, right? And like the negative made it reciprocal, so now it just becomes 4. Like if it was 1/4.
yes.
So then would it mean like if you like made a fraction that was equal to 1? Like,
Yeah, but then that would be changing the whole question. And
It's more like drilling in bacteria that are already on the desk.
Yeah, if you measure in grams.
see, that's why you guys should never put your hands in your mouth, and you should always wash your hands before eating. All right. So stop thinking about bacteria now. So these questions only. If you don't read this properly, then you're doing all of it. Okay. So just 2, 3, 5, 6, 8, and 11 questions are on Brightspace under 0 negative exponents. Okay, pretty straightforward with some word problems. So do try it out. That's the lessons for today. Tomorrow we will do a review. Okay, we'll start the review. Sounds good? Okay, so there you go. Voila.